This tutorial will show how to do exercise 410. It's on page 4-4 of the handouts, class 4, of course, for introductory AutoCAD. Here's the entire page if you want to screen capture it. And I got a close-up of a PDF of this page showing the dimensions of 410. We'll start a brand new drawing by clicking on the plus sign. And we'll start at the center circle. We'll draw this an arc for the there it is, radius 3 arc that will polar array these bolt holes. Notice these are 21 degrees apart, and there's 4 bolt holes. So this is a little more complicated than the last exercise we did that had 12 copies in a full circle. Click activate AutoCAD, click on circle center diameter icon. And as always, got dynamic input, polar tracking set for 90, object snaps on with the usual 5, end, mid, center, quadrant, and intersection. Every other status bar is off, and all status bars buttons are shown. Where was I? Center diameter circle. Click in open space somewhere. The small shaft hole is diameter of 1 unit. Okay, while I'm here, I'll put that circle on as well. Click on circle center diameter icon again. For review, the center radius is the one on the ribbon when you open up AutoCAD. You got to drop down and pick center diameter from the flyout toolbar. Okay, this will invoke the circle command, and it's D option, diameter option. So these are kind of, everything on this toolbar is a command with automatically options initiated. Again, click center diameter, hover, O snap, asking for diameter, that would be 2, enter. Now another diameter is this R3 here. Let's change the icon to center radius. O snap at the center, and that is 3 units radius. One of them is at the quadrant of this circle, straight across. So let's make the first one right here. We'll do the keyway last. That's a little tricky. Let's see, all of these bolt holes have a diameter of 3/8, 0.375 inch. So we'll drop down the circle flyout toolbar, pick center diameter, click at the quadrant of this 3-inch circle that's shown in red on the PDF to the right. And the diameter is 3/8. AutoCAD will understand that is just the same as 0.375. Hit enter. Now we can launch the array command. And okay, the polar array is up from the last exercise I did. Remember, rectangular array is on the ribbon when you open AutoCAD. So drop that down and pick polar array. So select objects. We'll select this 3/8 of an inch circle. Hit enter. I can't remember if week 4 has got another way of to be on the safe side. Let me repeat that. Polar array, I'll click with a direct hit to select the objects. Hit enter to conclude our selection set. Click the polar array button. Select the object to polar array. Hit enter to tell AutoCAD we're finished building our selection set. says specify center point of array. Well, that would be this center point here. Up pops the contextual ribbon. We only want, and there's a good and a bad order to specify. If they do things in the wrong order, you might have to redo them. I can't remember what the order is, but there's 4 holes. So let's change the item to 4. And we'll change the between angle. We don't want to fill 360. We'll change the between angle to 21. Click OK, and nothing will go wrong. There we go. Week number 8, we'll learn dimensioning. There is a way you can specify 3 points of a dimension. The vertex first, and I think center there, and then center there. But I'm confident it'll give us 21 degrees. Let's add the curvature at the top and bottom here. These are a radius of 0.5, both at the top and at the bottom. I'll drop down the circle flyout toolbar, pick center radius. Snap at the center of the top one. And that is a 5 unit rate. 0.5. Let me undo. Try that again. Circle center radius. Snap at the center. 0.5. Enter. Have we learned the copy command yet? Let me go back. Okay, go back to, well, let me stop the recording while I'm getting smart again here. Okay, I see in class number 4, we haven't learned the copy command yet, nor have we learned how to select multiple objects with just a couple clicks. So I'll continue selecting single objects and recreate them objects instead of copying. We'll go up, we got to make a 0.5 radius circle around this bottom bolt hole. Click on circle center radius icon. Snap at the quad. Whoa, what happened there? Okay, snap at the quadrant of the big circle or the center of the 3/8 circle and create a 0.5 radius circle. Now this, the dotted lines on the handout are just to show you that this is a line is a straight across from the 1 unit diameter circle to the 0.5 radius arc. So, 0.5 is, this 0.5 radius lines up with 1 diameter. So we can draw a line from quadrant to quadrant straight across. Let's go to the line icon, snap at the quadrant. Now, don't be careful. Don't snap at the intersection. That'll throw off the finished product if this were computer numeric control cut out. So double check you're on the quadrant of the 0.5 radius circle and draw it over. It could go all the way, but we're going to trim it back later, so I'll just stop right there. Enter. Let's draw this fillet here. This arc, this little curvature there, that is a radius of 2 units. 2x means on this drawing there are 2 features with the following dimension. The following dimension is R2 for radius of 2. So let's fillet between this line and this circle with a radius setting of 2. Covered fillet in class number 2, as I recall. Click on the fillet icon. And the start from scratch drawing begins with a radius setting of 0. So let's click on the radius option to change the radius setting to 2. Enter. Click the line near the end, not at the end, but close to the end and click the circle where you expect the arc to form. There we go. A circle does not get cropped off. An arc will, but not a circle during the trim fillet process. Okay, let's do this top one. Dotted line in the PDF shows it's to strike tangent to the hole for the shaft. So it'll be tangent up here, not at the quadrant, not at the intersection, but tangent. Might coincidentally be there. We'll see. Start a line. Remember the O-snap overrides? Just using the tangent O-snap override twice, I'm not going to change the 5 running O-snaps. I'll hold the shift button down, right click, pick tangent for this 1 point only. Tentatively say it's going to be tangent there. Now I'm back to the 5 O-snaps again, intersection, quadrant, center, endpoint. I need to use the tangent O-snap down here, not quadrant, not center. Now you need to use a tangent O-snap again here. Remember, an O-snap override is only good for a single point. And remember, O-snaps can only be used when you see the words specify and point in the command prompt. I'll hold the shift button down, right click, and pick this tangent O-snap override again. Again, you can type TAN, enter. And we'll say it touches there. And I believe because these circles are identical, it does hit at that intersection there. By coincidence, this circle and these 2 circles are both radius of 0.5. Shown on properties. Hit escape to deselect. I'll put the fillet in here again. Same way I did down here. Click fillet. The radius setting is already made 2 units from the last time I used this command, so I don't need to change the radius setting. I just go straight and select the first object. We'll click the line approximately where the fillet will hit. Could be out here, I suppose. And then click the circle where you expect the arc to touch. And why did it not work? All right, never noticed this before. Click fillet. I'm going to click outside the circle. There we go. Interesting. All these years I never noticed that. You gotta be anyway. What's left? Oh, let's draw a circle from here to there. Well, what's the radius? Well, we could do the arithmetic. Adding 3 and half of or adding 3 and 5 to get the radius of this black circle. Being incredibly lazy, though, I'll graphically select it. Click the center point there and O-snap at the quadrant there, and that'll give 3.5. There we go. We got to trim and erase. Remember this early in your training, I don't expect you to do the red broken lines or the sniper scope target icons. Let's erase that guideline. And we'll trim. Good habit to get your entire drawing in view. We'll trim. My AutoCAD has automatically got everything rigged to be a cutting edge. In class, you got to hit enter to specify that everything is a cutting edge. The system variable to make the change, I believe, is trim extend mode, and I forget what you set it to, 1, 4, on, off. Anyway, my AutoCAD's is the correct way, in my opinion, that everything by default is a cutting edge. So all I got to do is click outside of these two circles that are going to be used as cutting edges. Click outside of those. Oh, and I'll click there and there to get rid of those circles. All that's left now is this keyway. I'll hit enter or escape to finish the trim command. Notice that keyways are dimensioned from the bottom of the shaft hole. Some textbooks carelessly dimension them by the height of the teeth, the depth from that corner there. But the inspectors will put a tool in to measure from the bottom of the shaft hole to the top of the keyway. So let's draw a guideline from the bottom of the hole straight up 1.125 inches. 1 1/8. 1.125. Enter. 9/8 would work, but you can't combine a decimal and a fraction. I'll hit enter. Bend my cursor. That's the proper height. We're going to cut this 1/4 inch keyway. I'll hit enter or endpoint. Now, if we learn the move command, I can just draw a 1/4 inch line and move it from its center point to that end point. But that's next week, so we got to do a little arithmetic. Half a 0.25, 1/4 inch is 0.125, or 1/8 of an inch. So let's draw an 1/8 of an inch line both directions. Click the line icon. Snap at the end point, go one way or the other, 0.125, enter, and enter again. We haven't learned the mirror command, or I could reflect it straight across or copy it from endpoint there to endpoint there, but that's next week. So we'll click line icon again, click the endpoint again, polar track to the left this time, type 1.125, and hit enter. Should have continued straight down earlier, didn't think about it in time. Come straight down, and the intersection O snap will home in where an existing object is, and where an existing object and the polar tracking line intersect. Some odd dimension there, 0.1409. The inspectors doesn't care about that dimension, even if some careless textbooks might dimension the exercise right here. So just click with this odd dimension. And that's all we need for that side. Hit enter to finish, hit enter to begin the last used command, start the line command at that line. And again, I could have done this earlier, but didn't think in time. Come down to that intersection, click, hit enter to finish the line command. We got a little bit of erasing and trimming to do here to clean up. We'll erase the vertical line that was only used as a chalk line, and we'll trim this guy off here. Again, my AutoCAD automatically sets everything as a cutting edge, so I don't have to hit enter to select everything and to be a cutting edge like we do in class. I'll click there. We are finished. Now, before I'll hit escape or trim to get out of the trim command. Now, again, this polar array is a complicated single object. If you want to erase or move one of the circles, you'll have to explode it, like we did in the last exercise. I think that was 403. But the beauty of leaving a polar array intact instead of exploding it is you can modify the angle between, or the number or the fill angle, all those 21 degrees add up to 63. So let's leave it at 4, but it's going to mess up the top and bottom of this plate. But let's change it. Or on second thought, let's make it leave it 4, but change the angle to say 15. Enter. There. Now it's 45 degrees total. 15, 30, 45 angle here. Pretty cool, huh? How about we increase, leave the angle between as 15, but increase it to say, well, 7 will run off, but just for demonstration, I'll change it to 7 and hit end. Whoa. Okay. Apparently the fill angle overrides the angle between. So I'll have to go to I'll have to go angle between now. 1.5, enter. So this has got 15 degrees between each bolt hole. Again, you got to do these in the right order. Let's put it back where it was. 4 holes at 21 degrees between. Let's see if this takes an order. 4, angle between 21, enter. Good. Back where we were. And by the way, out here these are special icons. They're kind of advanced for our level, but you can specify, a smaller hole and replace one of these, I believe, with this icon. So you don't have to start all over or explode all but the first one, using these options here. We'll call that good. Save your file if you want. We won't need it for further exercise. See you next video.